think of a metal, you probably picture something dense, heavy, and rigid. But the 19th element on the periodic table, potassium, breaks all those rules. It has a density lower than water, meaning it can actually float, and it's soft enough to be sliced right down the middle with an ordinary kitchen knife to reveal a bright, silvery center. That brilliant shine won't last long. Within seconds of exposure, the metal reacts rapidly with the oxygen in the room and turns dull. In fact, ambient moisture is enough to damage it, forcing chemists to keep pure potassium completely submerged under a protective layer of mineral oil. If that oily barrier is removed, the threat is real. As it hits the surface of water, potassium tears the molecules apart. The heat spikes, escaping hydrogen catches fire, creating a violent purple flame. This leaves us with a contradiction, a volatile hazard that requires strictly controlled laboratory conditions. Yet, an average adult human currently holds roughly 140 grams of this exact same element safely inside their body. Human beings are essentially walking bags of water. If pure potassium explodes the second it gets wet, we have to ask why we don't erupt in purple flames every time we eat. We clearly don't, despite consuming it constantly. You'll find it in potatoes, spinach, avocados, yogurt, and of course those historically famous banana harvests. A healthy, balanced diet provides a steady supply of element 19 to our systems. Instead of filtering this element out, our biology captures incoming potassium and stockpiles it, burying it deep inside our individual cells to be used throughout the day. To survive carrying around a reactive chemical, there must be a structural difference between the metallic hazard sitting in a lab beaker and the nutrient hiding in our food. The answer lies in how nature packages things. Left to its own devices, the Earth never produces pure metallic potassium. It locks the element away by mixing it with other elements to form highly stable chemical compounds. It stayed locked away until 1807. That year, an English chemist named Sir Humphry Davy managed to tear potassium out of its stable, natural state, becoming the first scientist to ever isolate it. He did this using a process called electrolysis. By passing a strong electric current through molten potassium hydroxide, the stable compound split apart into tiny metallic droplets. This isolated, pure state is completely unnatural. The vibrating metal desperately seeks a chemical partner to restabilize, ready to react with almost anything. That violent reaction with water is the chemical panic of an artificially isolated metal rushing to restabilize. This is why we never encounter chunks of pure, explosive potassium in nature or in our meals. What we actually consume is potassium in its dissolved form. Inside your body, there is no solid metal. Instead, potassium exists as an ion, a tiny electrically charged particle floating in your biological fluids. Biology utilizes the element's reactive nature for a specific purpose. By moving these charged ions in and out of cells, the body can generate and conduct tiny electrical currents across vast networks of tissue. These invisible ionic currents are the mechanism your nervous system uses to transmit messages. Every time you think a thought or contract a muscle to take a step, you are relying on a flow of potassium ions to carry the signal. The stakes for maintaining these pathways are absolute. If your potassium levels drop too low or spike too high, those electrical signals falter. These highly regulated ion currents are responsible for dictating the steady rhythm of the human heart. The human body doesn't suppress potassium's volatile energy. It simply channels it, taming this explosive potential into the precise, rhythmic electricity that keeps you alive. That specific chemical utility spans the entire globe. Potassium is the 7th most abundant element in Earth's crust, found in minerals like feldspar and mica, and no plant on this planet can grow without it. Humanity figured out how to harness these reactive compounds centuries ago. From early manufacturing of bulk goods like soap, all the way to modern agriculture fertilizers and commercial batteries, our industries run on potassium. When astronomers point optical tools like this toward the sky, they detect potassium's distinct light signature in the sun and in distant burning stars, proving the element is a consistent presence across the universe. From the makeup of the stars to the chemistry of our factories, element 19 bridges the gap between the scale of the cosmos and our own industrial history. Potassium demonstrates the dual nature of chemistry. In its pure metallic isolation, It is one of the most violently destructive elements on the table. Yet, dissolving quietly inside living cells, it handles biology's most delicate, essential tasks. Without it, muscles fail and nerves go silent. Nature takes a volatile cosmic element and, by simply changing its form, creates the precision electrical charge required for a beating heart. But while potassium supplies the electrical spark for our survival, the physical framework holding us together requires something entirely different. Next time, we'll look at the element that literally built your bones.